Hello everyone, my name is Ogenetedrio Mamogo and you are welcome to Oxchem Academy. Now if you are new to my channel, kindly hit the subscription button below, also like, share and of course avail yourself to the lesson so as not to be left behind. Welcome back. So in today's class, we're going to be continuing for where we stopped in our previous lesson, which is oxidation number. So in our previous lesson, we talked about rules for calculating oxidation number of compounds and ions. Now, if you are yet to watch that video, kindly check it out in my channel. It is titled Oxidation Number. Okay, so please take note of that. We're going to be going numbers. Okay, so the first section we're going to be taking is one example, and it is what is the oxidation number of chloride. So we want to calculate the oxidation number of magnesium chloride. Now, first things first, remember when we're talking about the rules in naming oxidation numbers, we said that whenever an element exists in its elemental form, or rather in its free form, that is uncombined with another element, its oxidation number is 0. Okay, so please take of this question. It says, what is the oxidation number of MgCl2? So we're looking for what? Mg in what? MgCl2. Okay, so we're going to write our formula MgCl2. Now, because we are looking for the oxidation number of Mg, okay, I think I omitted that in the question. What is the oxidation number of Mg? Mg in MgCl2. So we are looking for Mg. So Mg becomes what? Our unknown. Now, solution. When you add up your oxidation numbers, it must equal the charge of that compound. So if a compound has a charge of -1, your oxidation number when you calculate must have a charge of -1. Okay, so we know that we're looking for magnesium and then chlorine. So what we are doing is that we are adding up the elements, or rather we're adding up the oxidation number of the element. So Mg, now chlorine, we already know that chlorine is a halogen, and because chlorine is a halogen, it has an oxidation number of -1. Okay, so chlorine, and mind you, chlorine has an oxidation number of -1, but if you look at this compound, there is a 2 attached to the chlorine, so we don't throw away the 2. Okay, so we say magnesium plus these 2, okay, so these 2 plus, that is chlorine in a bracket, equal to 0. Now, why is it equal to 0? It is equal to 0 because this compound does not, so we don't have any positive or negative sign present. So this equals what? 0. So everything you are solving for must equal 0. Okay, so that said, we can now solve. So Mg plus 2, remember this 2 is from chlorine, and then chlorine has an oxidation number of -1. So Mg plus 2, then in bracket -1, which is the charge of your chlorine molecule, equals 0. So we can now calculate Mg. Now, plus 2 minus 1 is what? Plus 2 minus 1 is what? 2 times, remember this bracket means times. Plus 2 times -1 is -2 equal 0. Mg will now be equal to plus 2. Why is it plus 2? Because your -2 will go over the equal to sign. So whenever a number goes over the equal to sign, it will change sign. So because -2 is going over this equal to sign, it carries a positive charge. So meaning that the oxidation number of magnesium in MgCl2, which is magnesium chloride, plus 2, which makes sense. Why? Because magnesium is an alkaline earth metal, and because it's an alkaline earth metal, it belongs. So you see that we have been able to prove that magnesium actually has an oxidation number of plus 2. Okay, so we're going to take another example.
So for our number 2 example, we're just going to be cleaning so that we
don't have to start all over. So for our number 2 example, what is the oxidation number of aluminium in
Al3, which is aluminium fluoride? So
calculate the oxidation number of aluminium in aluminium fluoride. So we're going to repeat the same process. Okay, so aluminium, okay, plus. Now we have 3 attached to what? Fluorine. So aluminium plus 3 in bracket F equals
0. And the reason it is
charge attached to this what? Compound. Okay, so aluminium plus 3 in bracket F equal 0. So aluminium plus 3. Now, if you remember our previous lesson, I explained that fluorine, which is a halogen,
is a very
the most electronegative element in the periodic table. And because it is the most electronegative element in the periodic table, it always has an oxidation number of -1. Always. Okay, so fluorine's oxidation number is -1 equal 0. So simple mathematics, Al plus L
times -1 is -3.
0. Okay, so
Aluminium is equal to plus.
went over the equal to sign. So that is to say that the oxidation number of aluminium in AlF3 is what? 3. So it makes sense. Why? Aluminium actually belongs to group 3 in the periodic table, and because it belongs to group 3, it has an oxidation number of 3. Okay, if you also remember when we taught how to write formulas, right, when we taught swapping of
Oxidation numbers, when you see AlF3, you already know automatically that these 3 attached
to fluorine belongs to aluminium. So you see that in chemistry, everything actually relates. So but for the purpose of this class, aluminium has an oxidation number of +3. Okay, so I'm going to take another example. So as I said, for the sake of not wasting time, we're just going to be changing the numbers and solving accordingly. So our next question is V2O5. Okay, vanadium oxide. So we're going to be looking for vanadium. That's the oxidation number of vanadium in vanadium oxide. Okay, so solution. So we're going to write it as usual, V2O5. Now we're looking for vanadium, right? But if you look at this, there is a 2 attached to your vanadium, so you don't throw that away.
So it becomes 2V plus oxygen is carrying
So 5. Remember, oxygen has a valency or an oxidation number of -2. I taught you that in the previous video, and I said there are only a few exceptions to this rule. But in the case of vanadium oxide, oxygen has an oxidation number of -2. So please take note of that. Oxygen belongs to group 6 in the periodic table. So everything will equal 0. Why? Because there is no charge attached to this compound. So we can now solve. So 2V plus
5 times
-10. So 2V minus 10 is equal to what? 0. Okay, so what do we do whenever you see a number attached to a letter? You collect like terms. So divide both sides by 2. So 2 here 1, 2 here 1, 2 here 1, 2 here 5. So that is to say that vanadium is
plus 5.
Okay, so take note of that. So I'm also going to take so please try and pause the video and attempt to solve some questions so that you know that you understand what I'm actually trying to explain. So, but now we have talked about compounds. Let us do some examples on finding oxidation numbers of polyatomic
Ions. Okay.
So as I said before, we're not going to clean the question. We're just going to clean the numbers so that we don't have to start afresh. Okay, so for this question, we're going to be taking sulfate group, which is a polyatomic ion. So sulfate group is a polyatomic ion. Okay, so we're going to be looking for sulfur. Take notes. We're going to be looking for sulfur in SO4. Okay, so sulfur plus. Now, oxygen, we already know, carries a charge of -2. That is the oxidation number. But there is a 4 attached to oxygen. So, S plus 4 in bracket, the charge of oxygen, which is -2, close bracket. Now, what do you think the total charge will be? Will it also be 0? No. Why? Because this compound carries a charge of -2. Remember, in my previous video, I explained that whenever you see a -2 charge, it means that this polyatomic ion gained 2 electrons. So a negative sign means gain of electrons. A positive sign means loss of electrons. So meaning that sulfate group gained 2 electrons. Now, because it carries a charge of -2, your total charge must equal -2, not 0. So please take note of that. So we can now solve. So S minus 2 times 4 is 8, equal to -2. Okay, so what do? -8 will now, S will now be equal to, your -8 will go over the sign and become +8. So -2 plus 8 is what? +6. I hope I'm making sense. So meaning that the oxidation number of sulfur in sulfate is what? +6. Okay, so please attempt these questions, pause the video, solve it, and then check if your answer is correct. So we're going to take another example so that we are sure that we all understand. Okay, so we're going to be taking phosphate group. So we're looking for phosphorus in PO4 3-. So phosphate group. So how do we solve? Okay, so phosphorus plus oxygen carries a charge of -2, but there's 4 attached to it. So 4 minus 2 equals to, then the total charge becomes -3. Okay, not 0, because it has a charge of -3. And as that rule said, the total amount of oxidation numbers must equal the charge. So meaning that our calculation must equal -3. Okay, so P minus 2 times 4 is 8, equal to what? -3. So P is equal to, your -8 will go over the sign and become +8. So +8 minus 3 is what? +5. So meaning that phosphorus has an oxidation number of +5. I hope we understand. We're going to be taking 2 more examples, but this is actually classwork for you guys to solve. Let me see how well you do in the comment section below. Okay, so I'm going to write the question on the board. Please, when you solve it, drop your answer in the comment section below, and so that others can also learn from you. So for the question, we're going to be taking 2 exercise questions. Number 1, which is to find the oxidation number of nitrogen in NO3-. So we want to find the oxidation number of nitrogen in nitrate polyatomic ion. And then the next example is, the next exercise is, what is the oxidation number of chlorine in chlorate? So what is the oxidation number of chlorine in chlorate ion? So attempt to solve this, and of course leave your answer in the comment section. If you are watching this video up to this point and you're yet to give us a thumbs up, please do that. Also, if you have any questions as pertains this topic, let me know in the comment section below. Of course, like, share, subscribe. I will see you in your next class. I remain your tutor, Ogenetidro Mamogo. Have a wonderful day.